I'm Michael Smolensky. I'm founder of a company called Auto Contracts. I'm aware that you guys are running over time, so I'm going to try and flick through these slides very quickly. So I'm a member of the Ethereum Australian Meetup group as well, and the Telegram group. So I know quite a few of the guys there because I lived in Sydney for a while, and a bit of an active member of the community there. So today I'm going to be talking about privacy for public blockchains. I was recently over in New York and was a winner of one of the Hackathon prizes there for part of this work, along with the Blockbox group from Australia. So well done to them. So I'm going to try and flick through these slides pretty quickly, and then hopefully just do a demo of what I've built. So there's also a white paper about this prototype. So if you take a photo now quickly, if you go to autocontracts.io, you'll see the white paper. And I think that address is on the next slide. Okay, so this is where I'm based right now in Mallorca in Spain. And we've got a little startup community out here doing some blockchain stuff. I'm also working as a consultant in Germany for a share and charge blockchain solution for charging electric cars. So why did I build this permission blocks technology? Well, I was in Australia in 2015 and end of 2015, and I entered a Citibank competition for a real estate blockchain concept. And so that got me into the finals, got a bit of publicity, also came second in a Santander Bank competition for this concept. However, back then in 2015, early 2016, there were still some issues with blockchain technology. So I like to call them two elephants in the room. One of the elephants is around scalability. So vanilla Ethereum or Bitcoin is too slow for most use cases. So for example, Ethereum can process, I don't know, around 7 to 10 transactions per second. But there's now new solutions to make that faster. And the other white elephant in the room was around privacy. So that real estate solution that I had basically was all about recording rental payments on a blockchain. And obviously you can't have that public for everyone to see. So I set out to try and solve that problem of privacy on public blockchains. So just a quick word about private blockchains. You might have heard this before. I was actually an advocate of this as well before we had any other solutions. So private blockchain is basically just a group of nodes that are basically a club. So you can also hear them called permission ledgers or consortium blockchains. So what it means is that you have to be approved to become a member of this club. Once you're in the club, then it's just a normal blockchain and you can see everything on the blockchain. Now, it's not really practical for most use cases because maybe some of those nodes are your competitors, or maybe you just don't want to share all the information. You know, sometimes it's personal company information or whatever. So what I started with trying to solve this problem is how do we make the state of a smart contract private? So this is my little model of a smart contract. So F1 is a function, so you have an input and you get an output. And there you can see the state inside the contract. So the way I try to solve this is those Ethereum developers in the room will know that you can do a function called send transaction. And what that will do is make a call to a function, and then that will be persisted on the blockchain and broadcast to all the different nodes in the network. The other way you can do it, make a call to a function, is called using a call. So a call doesn't actually do any broadcast to the blockchain network. All it does is call the function locally on your local node they call it a dry run in the documentation, just to test that the function is working. So what I used is that second point of a call to be able to call a function, but not let anyone else in the network know what the data is that you send. So that's basically the solution in a nutshell. So how do we do it? Some of you have probably heard about functional programming. So rather than store the state on a blockchain, what we do is if we have state 0, we have parameter 1, we feed that into the function, and then we get state 1 out. So it's a way of refactoring the Solidity code. So you're never storing state in the smart contract. Yet the smart contract is still able to process the function. And then likewise, state transition 2, you then take the previous output and feed it through the smart contract, and you get the output. And just a little note here, I think Luke Williams is in the audience. He actually wrote a paper following my paper that improves on this whole refactoring process. So you can actually just write a Solidity smart contract as you would today, and it will automatically refactor this for you. Okay, so if we're going to take the state out of a smart contract, well, where do we store it? Well, most solutions today that you'll see out there talking public, what they do is they say, okay, we'll just store the state on an external database. And what we'll do is we'll take a hash of that data, for example, and then we'll just store the hash of that data on the smart contract. Now, that kind of defeats the purpose of having a distributed, decentralized network because, you know, who owns this database, and what's if they decide they don't want to play ball anymore or whatever. So the real way is actually just to have a distributed database storage system like this. And for this solution, I've chosen to use IPFS. I'm not too sure whether many people in the audience have heard about that, but it's quite a mature technology. One of the founder was a speaker at the Consensus conference in New York, and he has quite a lot of following and quite a lot of popularity. Okay, so IPFS is called the Interplanetary File System. What it is content address versioned peer-to-peer file system. So what that means is you take some data and you can create a hash of that data. So that's like people call it a fingerprint. So that hash is a unique ID of only that data. So if the data changes, then the hash will change. So they use that hash like a web address. So you can use that hash to find that data anywhere in the network. So rather than using, like, for example, an IP address, you use the hash address to find the data. So what is permission blocks? Well, this is a very simple diagram. It's the integration of Ethereum with IPFS. And what we're doing is we've got an author. This is one node here, and this is another node here, and they're communicating via 2 channels. But the integration point is an authorization mechanism, so that when the smart contract, so for example, when this node is trying to request data from this node, it goes through an authorization process to query whether they're allowed to have the data. If they are, then the data gets transmitted. I'm also using Tendermint rather than the standard proof of work algorithm for Ethereum, and that makes it an order of magnitude faster. I probably can't go into that. Maybe someone's got questions about that. But basically, we get up to 10,000 transactions a second rather than around 10. Yeah, so this is using permission blocks. It's private sharing of state and secure transmission of data. Okay, I don't want to go into this too much, but this is the network architecture. So there's different nodes here. So some are validators, and that's part of the Tendermint architecture. Yeah, don't want to go into that. We can talk about it later. So using this architecture, we get a governance model, we get scalability, and actually there's no gas in this model. So you can run smart contracts and you're not going to be charged any gas fees, which is quite good considering the price of Ethereum at the moment. Okay, so I'll jump into a demo of what I submitted at the hackathon in New York. You can also, if you go to auto contracts, you can run the demo. It'll take you to the GitHub page, and then you just run this Docker image. Okay, so let's hope the demo guides are going to be good to me. So what I'm doing is I'm running 2 Docker containers. So these basically are acting, because I'm using one computer, I have to simulate 2 computers. So this is running the prototype, so it tells me to open my web browser at that address. And this is the graphical user interface for it. It's quite simple, but it just kind of shows the concept. So this is me logged in on this device. If I go back and open the address that it tells me on that device, okay, so we have like 2 devices, and the idea is that rather than going through a central intermediary, like for example, Google Drive or something, where you go through a cloud service to transmit a file, you can actually transfer a file or data of a smart contract from one device to the other. So if I go here, contracts. So the hackathon challenge in New York was for a microinsurance application, and I just showed how in the value stream there's a whole lot of due diligence and documents and stuff like that that needs to be collected, and this is one way of applying this technology. So here I'm loading up a contract. So this is a view of a smart contract. So all this information up here is actually private. So they're attributes of the smart contract. So it's all the stuff about this particular insurance contract. So on the blockchain, you won't see that. The only thing you see on the blockchain is this data here, which is the blockchain metadata. So for example, I can search for that. And when I search for it, I only get the blockchain metadata. And for me to be able to see it, I need to unlock it. So I need to give it a signature ID. And the signature ID is just a Ethereum account. So you grant permission to Ethereum accounts. And as you can see, for example, if you click on this link here, this is one of those IPFS hash addresses. It's meant to be like an underwriting document. Or you click on the farmer, that opens up a farmer smart contract, and then you click on this IPFS address, and you can see the, for example, this is just a certificate of title for the property. So it's a way that you can attach not only object data, but also files, documents, videos even, anything that you want. And then I could go through and grant myself over here access to this particular one. So signatures. So enter that signature ID. It says, okay, that's this guy, which is me. And then I could click grant. And now you can see that I've been granted permission to see this smart contract. So I can go back and search for that and unlock it. And yeah, now I can see the full details of that smart contract. And then I can click on the link. Sorry. and I can see that document. So the document went from that device directly to that device without any database or intermediary in between. So that's the demo. Go look at the white paper if you're interested in learning more details. So what's next with this technology is my last slide. So I'm going to continue with the Microinsurance for Africa project. So a consortium of insurers in Switzerland are interested in seeing through this prototype and seeing where we go with it. But before I won the hackathon, what I was thinking about is an Amazon chain. So that's like a digital bookstore where people can, where creators of digital content can then sell it directly to their readers, to their audience. And this can start with academic books, for example, and then move on to maybe music or video. So that's the end of my talk. I'm keen to hear from any developers that want to get involved, or anyone else that's just generally interested in this technology. So with that, we can open it up to the audience for any questions, or you can get off to the pub and have a beer.
Maybe like 2 questions, or if anyone got any questions? No questions. 1 question. Yeah. So the question is like, what do you mean by getting involved? Are you looking to build it out or add more features, or what?
Yeah, so for example, the ICO that I'm thinking about doing, I'm considering whether to make this an open source project, and then if there's enough interest in the community to actually contribute to the project, then yeah, we can probably make an open source distributed model for building this Amazon store. So I'd be keen for people that are interested in that. I mean, Luke Williams is in the audience, and he's written a bit about the white paper. So anyone like Luke or anyone else that's interested in helping or contributing, then I'd love to hear from them.
Do you have any estimate of what you'd be able to raise with something like this?
An ICO, I have no idea, but I've done a little bit of research, and it's super expensive to actually start your ICO journey. You need a lot of money for promotion, management, and administration. You need community managers and things like that. So, for example, if you've got to watch all the different forums. So if someone's slagging off your white paper saying this is a scam, then straight away you've got to have a response about that. So people that have raised ICOs have told me that you need in the region of 80,000 to 100,000 euros just to promote, to do the roadshow before you do an ICO. So yeah, they used to say ICO, well, you used to hear that ICOs were a good way to raise money for an open source project. It sounds a bit difficult.
Yep. Yep. Okay, I'm going to summarize that. Have you thought of using it for healthcare? Because you've had like siloed healthcare providers not sharing data across to each other. Yeah, have you thought of using this for healthcare?
Well, actually, I wrote a LinkedIn article just recently about the ransomware attack. So if you go to my profile, Michael Smolensky, you'll see me talk about that. I just use it as a plug, actually, for my work. talking about how you could use such a system for medical records, and rather than the or health records, rather than the hospitals having your health record, you actually keep your own personal data on your own devices, and then you grant permission to your physician to see, all of that data or part of that data. And actually, I was just reading recently that a lot of medical records are quite unstructured. So a lot of them are just images, for example. So maybe this technology would be a good application where it's a whole lot of unstructured files and X-ray photos, what have you.
Cool. A lot of people want to talk to you about that same problem.